Hey guys, welcome back to the channel EduCool Zone. Today we are going to look into the sixth type of operator, which is bitwise operator. So let's get started. First, let us understand what bit means. Okay, if you have seen my earlier lectures, I have explained that the machine only understands binary language or binary codes. Okay, so what is this binary codes? Binary codes consist of zeros and ones. The string of the zeros and ones is nothing but binary codes. The only thing that computer understand is this binary code. So you might ask yourself a question that this program is particularly an instruction given to the machine. Then how is it understood by the computer? Well, I have said that this entire code is going to be converted into zeros and ones as by the compiler. Okay, this entire code will be converted to this binary digit using compiler, which acts as an intermediate between user and the machine. Okay, so now we have this many operators. So what do we mean by bitwise operator? Means you're going to perform operation on this bit level. Okay, so means if there is 0111, you're going to perform operations on this. The operator used to perform operation on bits are this operator. Okay, so let's see from the first operator which we are going to discuss is bitwise AND operator. Okay, don't get confused. This is double AND, which is nothing but logical AND. This is single AND, which is bitwise AND. Okay, this is again bitwise OR. This is again bitwise NOT. This is bitwise XOR. This is bitwise left shift, and this is bitwise right shift. Okay, so let us discuss each of this with an example program. Here I have taken two variables, which is a and b. For a, I have declared the value 5. For b, I have declared the value 3. So this value is going to be converted into bits. So this conversion of integer to the bit is going to be taught in detail in the further lecture. For now, just understand that the the binary value of 5 is 101. Okay, and the binary value of 3 is 011. Just understand this much. Now we are going to perform operation on this bit level. So the first one is bitwise AND operator. Okay, so in the place of a, we'll be having 101, and I'm going to next line and show you. So in the place of b, we are going to have 011. So we are going to perform bitwise AND operation over here. Okay, so what do we mean by AND, bitwise AND? So bitwise AND means it is going to give 1 when both the value is 1. For example, in this case, here there is 1 and here there is 1. In only this kind of condition, it's going to give the output as 1. Remaining rest of the condition, it's going to give the output as 0. Okay, so now if we see the result, so here if we see it, 1 into 1 and 0 is going to give us 0. Okay, let me just comment this. 1 and 0 is going to give us 0. Now again we have 0 and 1, which is going to give us 0 again. Now we have 1 and 1, which is going to give us 1. So this is the new binary operator which we have acquired by performing bitwise operation on 5 and 3. Okay, bitwise AND operation on 5 and 3. So now the value for the 001 is 1. So now this 1 is going to be printed in the place of %d, as you can see over here. Let me just run this program. As you can see over here, the first output is 1, which we got from A, bitwise, and B. Okay, this is about bitwise AND. Now coming to bitwise OR. Okay, again the same thing. Here the value of 5 is 101, and the value of 3 is, so we are performing OR operation. The value of 3 is 011, which is going to be equals to, so first let us understand how OR works. So OR actually is like addition. It's like 1 plus 0, it is 1. 0 plus 1, it is 1. 1 plus 1, it is again 1. It only gives 0 when both the inputs are 0. So in this case, here the first one, 1 plus 0 is 1. Okay. The next one is 0 plus 1 is 1. The third input here is 1 plus 1, which is 1. Okay. So the value for this binary digit is 7. Hence it is going to print 7 as output over here. Okay. So now we are going to learn about the bitwise NOT operator. Okay. So bitwise NOT operator can be performed using only one single variable. Here I am using the variable B. B stores the value 3. So the binary code of 3 is 011. So I am going to perform NOT operation, bitwise NOT operation on 011. So how will it going to be performed? Basically, it's going to convert this entire thing into reverse. For example, here it's 0. It's going to give it as 1. Here if it's 1, it's going to give as 0. Okay. Here if we see it, so our output is going to be 100. 100 is actually the actually stores the value 4. Okay, so since it is not, it is going to give it in negative. Okay, this is going to be given as a negative output. Okay, only this happens in NOT. We are going to discuss in detail why it happens in the further lecture. For now, just understand this: while you are performing bitwise NOT operation, it is going to give the output in negative. It's going to convert all the zeros and ones to its complement, and then it's going to return the value in negative. That's all. It's going to return this 4 as -4, as you can see over here in the console output. Okay. Now coming to the XOR operation. Okay. So here I'm performing XOR operation between A and B. So as you know, the value of A is 101 and the value of B is 011. We are performing the operation XOR. This is the symbol for XOR, and the value of 3 is of course 011. So what does it do? Well, if both the inputs are same, it's going to give as 0. It's going to give the output as 0. Okay. We are going to discuss about each of these truth table as well in the further lecture. Now just understand this in simple terms. This both inputs, if this both input are same, then it is going to give the value as 0. If it's different, it's going to give the value as 1. Okay. Here the first one you can see over here, it's 1 and 0, right? It is going to give the output as 1 since both are different. These both are different, right? 1 and 0 are totally different. So it is going to give the output as 1. Again, coming to the second bit, which is nothing but 0 and 1. Again, these both are different. So it is going to give the output as 1. Now coming to the third bit, which is having 1 and 1. So this is going to give the output as 0. So this is the binary conversion of A and B using XOR bitwise operator. Okay, so now the value for this is going to be 6. Okay, as you can see over here in the output console, the 6 is printed in the place of A XOR B. Okay, now coming to the next type of bitwise operator, which is left shift operator. Okay, so what do you mean by left shift operator? So this can be again only performed using one single variable. Here I am using A for performing the left bitwise operator. Okay, I am going to perform left shift. I'm going to shift one digit to the left. That's all it means. Okay, let me just show you. So in computer, if there is nothing, it's going to be stored like this. Okay, 0000, and the value of A is 101. Okay, that's all. It's going to be stored something like this. When I say move one bit left to leftwards, which means because I'm performing left shift over here, it is going to move one bit left side, means it is going to move 1 to left side. Now here there is going to be 1, in place of 1 there is going to be 0, in place of 0 it's going to be 1. So there is 1 extra over here. In place of 1 there is going to be 0 because that's empty. Okay, so this is the value which we are going to get after doing one digit left shift in the variable A. Okay, which consists the value 5. This particular binary code is the example for 10. I mean, it consists the value 10. Okay, as you can see here in the output section, it is printing 10. Okay, now coming to the right shift operator. Again, right shift means it's going to move one bit towards right. Here you can give how much ever bit you want. If I give it 2 means it's going to take. Okay, for now let us understand let us just understand about one bit moving towards right. Okay, so this is right shift. I'm performing right shift for the variable B, which consists the value 3. Again, the binary digit for 3 is 011. In computer it's going to be stored something like this, followed by zeros, and it's going to be 011. Okay, now I'm saying to move one shift, so to shift one bit right. Okay, here if I shift one bit right means it is going to remove the last one over here. Okay, it is deleted, that's all. So because there is no further continuation of that, it will be deleted. Then we are going to have only 0000 and only 1. As you can see over here, we have already got that. So the value of 001 is 1. So the right shift of the B variable is going to give us 1 as output. Okay, so this is all about bitwise operator. Okay, I know it's a bit difficult. It's not difficult. If you have not understood the concept of conversion of integers or decimal to bits, it is going to be a bit difficult. That will be covered in the later lecture. So if you have any doubts, make sure you put it down in the comment section. So if you have liked the video, please if you have enjoyed the video, please like, and make sure you subscribe to our channel EduCool Zone. Thank you for watching the video.